So first of all, thank you for joining us in this presentation and for showing interest in this research paper. Jen and I are truly honored by the attention the paper has received, especially as this subject and the research behind it hold a special place in our hearts. So this paper is developed by Jen and I, taking also in my PhD research project spanning the years 2019 to 22, focusing on the topic digitalization in shop floor management environment. So why do we find this topic relevant? Yeah, initially the research was motivated by an empirical gap observed during extensive time spent in various manufacturing settings. Generally, John and I struggle to find evidence explaining why digital transitions in shop floor management practices continue to rely on analog visualization dashboards when handling shop floor tasks instead of embracing new and modern trends that aim to enhance value creation through data usage enabled by concepts such as smart manufacturing or Industry 4.0. As you can see in the slide, these are examples of type of analog visualization dashboards John and I observed being used as a primary means to handle contemporary shop floor tasks today in the manufacturing environment. And from this, we naturally became curious about why manufacturing companies, despite promoting quite prominent digitalization strategies at corporate levels, not yet had focused on digital transitions of these dashboards. So following the theoretical literature on the subject, such digital transitions hold potential to unlock significant new opportunities. So to explore this further, we start by asking quite direct questions such as what are manufacturers waiting for, what are hindering them to embark on such digital transitions, and how to get started. So to achieve a baseline understanding, Jill and I initiated an investigation by conducting a survey on the subject, followed by a workshop involving around 40 manufacturing companies. So although we learned that the vast majority of these 40 companies expressed strong desires to embark on digital transitions of their shop floor dashboards, we found that they lacked clarity and consensus on key concepts and definition to this end. So we saw that this lack of shared understanding prevented them to fully identifying their goals ahead of this transition, leading them to significant roadblocks early in the process, which left them struggling forward to move forward effectively. So to address this empirical gap, we conducted longitudinal intervention-based research studies spanning 4 years, starting in 2019, where we focused on companies with distinct manufacturing setups and those companies that had begun at digital transitions of their shop floor visualization dashboards. So what we actually wanted to do was to explore the fit between visualization dashboards and the handling of contemporary shop floor tasks. And to do so, we first carried out a pre-intervention-based research study in 2 large international manufacturing companies referred to as Brauer and Charlie, where we assessed the current state to achieve an initial understanding of what was essential for exploring and understanding how to design and evaluate digital-enabled shop floor visualization dashboard effectively in our intervention-based research study in a primary case company, Alpha, a large international wind turbine manufacturer. So now I'll hand out a word to John, who will share more about our intervention-based research journey.
Thanks, Pernille. Our intervention-based research unfolds as sequences of interdisciplinary actions aimed at exploring and elaborating the current and desired state of using dashboards to manage shop floor tasks. Generally speaking, the means enabling the transition from the current to desired state is a knowledge-generating journey which combines academic knowledge, practical knowledge, and artifacts portraying the current state, TO in the figure. The journey of the intervention-based research involves various means illustrated at TO, T1, TN in the slide, which, however, should be understood as a non-linear approach to transform the current state into the desired state, TN, rather than a straight journey as indicated in the slide. To guide the intervention-based research journey, we used a task technology fit construct. In an abductive manner, we adapted the TTF construct to analyze and evaluate the digital transition of shop floor dashboards. We identified that shop floor tasks are associated with performance management, continuous improvement, and/or takt time compliance activities. Additionally, drawing on our practical insight along with a narrative literature review, we clarified that the dashboard functionality requirements are related to communication, structure, and information processing functionalities. While we observed clear fit and misfit situation between dashboard functionalities and the handling of shop floor tasks, we also experienced situation of partly fit, to why we developed this 3-level framework for analyzing and evaluating task technology fit. To build a strong foundation and support potential finding from our longitudinal study, we conducted an exploratory pre-RBR study within 2 companies, Brau and Charlie. The pre-RBR proved valuable and served us with an appropriate foundation to initiate our engagement within Alpha. The findings from this cross-case analysis enhance our understanding of the current state of the digital transition of shop floor dashboard, and it also provided additional insight into using the TTF framework when designing and evaluating a dashboard affording task technology fit within Alpha. We were a part of 2 design projects, one led by a lean manager and the other led by a data scientist. In both design projects, the participant did either consider the design from an operation management perspective or from a technology management perspective. Both project teams did not realize that the design of a digitalized dashboard required a combination of operation management and technology management guideline principles. We, the 2 authors, put many efforts into bridging the 2 mindsets, and gradually it was realized that the constraining factor for reaching desired state was an immature enterprise architecture. At the end of the day, our exploratory research did not lead us to the desired state. The actual state of the solution was a dashboard providing fit for 6 of the 8 desired functionality, 1 partly fit and 1 misfit. By combining the gap between the desired state and the actual state and looking at the means used during the intervention-based research with the existing scientific knowledge, we suggest a grounded proposition regarding guidelines that should be applied in future dashboard design and deployments. Manufacturers initiate the digital transition of shop floor dashboard without fully understanding the needed functionalities and the technical changes required in the enterprise architecture. We showcase 3 potential, overlooking the importance of defining the needed functionality and the technical prerequisites for the digital transition. Prior to initiate a digital transition, manufacturers should investigate potential differences between desired functionalities and technical feasibilities, followed by tailoring the enterprise architecture based on desired functionality to handle shop floor tasks. When contrasting the differences between the actual state and the desired state with the prevalent literature, we discover some decontextualized findings. Our intervention-based research demonstrates that the prevailing literature defines the desired state effectively, but the design principles to achieve this are either detached from smart manufacturing shop floor or lack guidance for real-time sharing of processes and resource details. We advise both academia and practitioners to use their professional knowledge and social interaction to bridge operation management principles and technology management design principles aligned with Van Agten's engineering OM transfer perspective.